Okay, so show that omega minus 1 multiplied by omega to the power 4 plus omega cubed plus omega squared plus omega plus 1 is equal to omega 5 minus 1. This one's just algebra. Or expansion, if I multiply this out, it'll be to the power 5, 4, 3, 2, and then omega, which is what this is being represented. This is here. Minus 1 multiplied out, you'd have a minus omega 4, minus omega cubed, minus omega squared, minus omega minus 1, which is this. You'll then notice that everything cancels. Omega 4 cancels out with minus omega 4. These all cancel out, leaving you with omega 5 minus 1 there. The next question says, deduce that omega 4 plus omega cubed plus omega squared plus omega plus 1 equals 0. Notice that we had z to the power 5. It's probably worth considering this. We had z to the power 5 as the original question. So what's happening is it is a, if I could judge, I can find it. It is this concept here where you have your 1, then you have your next root, and then you have your root after that, and they connect up in a manner to produce 0. 1 plus omega plus and so on. Notice we had 1 omega and omega squared for z cubed. For z5, which is what this question is, we'd have 1 omega, omega squared, omega cubed, omega 4. So it's saying, is there a way you can deduce that? Well, there's many ways you can deduce that. Technically, you could find omega squared, cubed, 4, 5, use De Moivre's theorem, add them all up and show. But another way of doing it is we could utilize some of the algebra we have here. We know that omega 5 is 1. Since omega 5 is 1, then omega 5 minus 1 is 1 minus 1, which is 0. I'll say that again. So we have omega 5 is 1. That's this question here. You can see there is my omega 5. It became equal to 1. Since that is the case, then a 1 minus 1, omega 5 minus 1 is 0. As a result, then, we can say that this thing here, this omega 1 minus 1 minus all of this, if we take all of that, there it is manifesting there. It is equal to this, which is equal to 0. So we know, therefore, that this here is equal to 0. Might be better to make that clear. So therefore, this here equals 0, we know that, and this is probably not the most legit way to look at it, but we could also consider it in terms of language. This multiplication can be said to represent the word and. We're saying that omega minus 1 and omega 4 plus omega 3 plus omega squared plus so on and so forth, that's from omega cubed. This and this equals 0. So that means this equals 0 and this equals 0, which means therefore this right part here. So we're saying this here equals 0 and this here equals 0. Since it's an and, they both do, then that right part of the term therefore must equal 0. And rather than expanding it out using De Moivre's theorem, which you could otherwise do here, you can turn this into a 5, a 4, a 3, a 2, and a 1, and then add them all up. You can utilize that concept to get your solution.